Good morning, class. Today we will start with the topic discovery of electron, and we also study about the cathode rays and its property. Okay, so in 1803, John Dalton gave the concept of indivisibility of atom, but his concept lasted toward the end of the 19th century. So it was found that the atom was composed of subatomic particles such as electrons, protons and neutrons. These particles are called elementary fundamental particles. The electrical nature of the matter was already founded by the Greeks. So they found that if any hard, transparent, yellowish brown substance which could be electrified by friction, so the production of the feeble electricity by rubbing materials such as glass rod with the silk cloth or during combing of dry hairs was first recorded by William Gilbert. So William Gilbert was the one who observed that the electricity can be produced by rubbing the two materials. Okay, so he also observed that there are two type of electrical charges. One is positive and other is negative. The experimental evidence of electrical nature of matter came from the experiment of Michael Faraday, who showed in 1833 that the flow of the electricity is due to the flow of the electrical and when the electricity is passed through the electrolyte decomposed to give the constituent of element. So the term electron for the fundamental electrical particle was first suggested in 1874 by J.J. Stoney. So he was the one who suggested this term electron, and the first experimental evidence was given by J.J. Thomson about the electron. So J.J. Thomson was the one who first experimentally showed about the existence of electron. So this was the basic we should know before coming to our topic, that is discovery of electron. Now in 1879, William Crookes shows that when the electrical discharge at very high voltage is passed through a gas at 0.01 mm of mercury pressure, the discharge tube, the glass wall opposite to the cathode, begins to glow. So for this we need to first see the experimental setup. So this is the experimental setup. You all can see a discharge tube. The length of the discharge tube is given, that is 60 centimeter long. Now you all can see that two metallic electrode is placed at the two end of the discharge tube. You all can see. So one is anode and one is cathode. The positive is anode and negative is cathode. Okay. So now one vacuum pump is also present so that the air which is present inside can be vacuum out or pumped out. Okay, when the air inside the discharge tube is at now William Crookes started doing his experiment. So he at 1 atmospheric pressure he observed that what is the condition, and he also applied very high voltage of 10,000 to 15,000 volt he applied. So the electricity does not flow through the air in the discharge tube. There was no any change. Because why there is a no change? Because the gas at the normal pressure is poor conductor of electricity. Okay, so but then what he did, he reduced the pressure. First he reduced from 1 atmospheric pressure to then 0.01 to 0.001 mm of mercury. Till there he reduced the pressure. Voltage was high and he keeps on reducing the pressure. So he reduced the pressure of the inside the discharge tube to 0.001 mm. Okay, so what he observed, that the green color start glowing opposite to the cathode. So you all can see the cathode. So opposite to the cathode, that means at the end of the anode, at the anode side, the green color start glowing. You all can see in the picture the green color starts glowing. Okay, so why this green color starts glowing? The green glow is due to the fluorescence of the wall produced by the bombardment of the glass by invisible rays coming out from the cathode. These invisible rays coming out from the cathode are called cathode rays. Thus, when the electrical discharges pass through the gases at very low pressure, cathode rays are produced. So, now the cathode rays are produced. Now, let's see what are the where we can see this cathode rays. So we can see in the neon sign advertising board, we all can see, then fluorescent tube we all can see, sodium vapor lamp also, and in the television tube also we can see this cathode ray. Okay, so this green color we can see there also. Now let's see the properties of cathode ray. So we will see one by one the property. Cathode ray travel in a straight line, you all can see. So when the opaque solid object such as metal cross is placed on the path in the path of cathode ray, the shadow of the metal cross is formed on the wall opposite to the cathode ray. That means the light cathode ray travels in a straight line. Now second is cathode ray produce the mechanical effect. Okay, when the cathode ray produce mechanical motion of the paddle wheel when it is placed on the path of the cathode ray. Now what is the third point? The cathode ray are deflected by the electrical field. When the cathode rays pass through a strong electrical field formed by placing a positive charge or the negative charge plates on their path, so they deflected from the positive plate to their path. So you all can see that it is deflected from negative part to positive part when any charge plate is kept on it. Now what is the next? Cathode ray is deflected by the magnetic field. So if the magnetic field is applied, so when the magnetic field is placed, the cathode ray are deflected toward the north pole of the magnet. When the cathode ray is placed through the electrical field and the magnetic field in the succession arranged the perpendicular to each other, and the electric and magnetic field strength are adjacent in such a way that they balance each other to produce no deflection. Means if you will put both the field, so they will balance in that both the field and they will show no deflection. Fine. Now next is cathode ray. Heats the tin metal foil to its become the incandescent. That incandescent means to white hot. Okay, now next point is cathode ray impart negative charge to the object to their path. So that means when the cathode ray are allowed to fall on the object acquire negative charge. Why negative charge? That's why we will find that the charge is coming out as electron. So this indicates the cathode ray are energetically negative charge particle. Okay, now cathode ray causes the ionization of the gases. So when the gases are exposed to the cathode ray, they occur the ionization of the gases. So this also indicates that cathode ray are energetically negatively charged particle. Now what is the next point? Cathode ray produce X-ray on striking the metal target. So when the cathode ray is directed toward any metal target, suppose in copper or molybdenum, okay, so if like this metal it is targeted, so penetrating the X-ray is generated. So there the X-ray is generated. Okay, now cathode ray produce the fluorescence. The cathode ray produce fluorescence in the glass wall of the discharge tube as well as on the certain substance such as zinc sulfide. Okay, so these were the properties of the cathode ray, and this shows that the gas in the discharge tube is composed of the atom and all the atom contains electrons. On application of high electrical voltage, the electrical energy knock out some of the electrons from the atom of the gas taken in the discharge tube. So these electrons constitute the cathode ray. Hence the emission of cathode ray indicates the presence of electron in the atom. I hope you all have understood. Thank you, class.